Okay. Hi everyone. Good morning. Admit. So it's already 10:06 a.m. So I assume you guys are already wide awake. However, there are few students who are still not here, but I think we should proceed with our lecture today. Okay. So before okay. So before we start our lecture, let's take a look at our course plan. So we already in week 11 already. Yeah, week 11. So today we will go. Last week we already covered chapter 9, which is software architecture. This one. If you remember last week, software architecture. This one we already covered last week. So this week we will proceed with system architecture together with this week. Okay, system architecture. So, right. So let's proceed with system architecture. Okay, system architecture and influences. So today, this week, we will cover on chapter 10, which is system architecture and influences. So okay, this is the course outline for today. This is the course outline for today. For this chapter, we will learn what is meant by system architecture in a development project. However, last week I already give you define the concept of system architecture. But this week on this chapter, we will see how we apply system architecture in a development project, and then what is the architecture views, why we need to model the architecture of a system, like what the use of it, what is the function of architecture model, and what is the factor influence the architecture of a new system. Okay, the factor that will affect the architect of the new system that we want to design. Okay, so this is the course outline for this chapter, which is 54 pages. However, for this chapter, it's quite different with the previous chapter too, because in this chapter, um, less diagram compare with previous chapter and previous week. You learn a lot of diagram. It is different with this chapter because this chapter usually no, it's not usually, mostly on the concept of software architecture, software or system architecture. Okay, so this one is the definition of architecture. So architecture, like I already explained last week, architecture is the view. It's not the view really. Architecture is the conceptual model. Okay, before we look at this slide, I give you what is the definition of architecture. But architecture is actually art of the practice of the designing, construct, construction. Okay, so how do we put architecture in a software development? So like I said just now, architecture is actually the art of practice to design our system or our software development. So what is a system architecture. So system architecture is actually the conceptual model that defines the structure of our system. So as you can see here, architects are trained to take you brief and can see the big picture. They look beyond your immediate requirements to design flexible building that will adapt the changing needs of your business. Okay, this one is the general definition of on architect view. So in software development or in SDLC, we call as software development lifecycle. Okay, before we design a system, like mentioned in the previous slide, before we design a new system, there is one part. Usually, it will be done by the system architect. I'm not sure if you have heard this before, but there's one part system architect. So the system architect will involve in the earlier phase of our SDLC. So as we already cover system development life cycle, we have planning, analysis, designing, implementation, and maintenance. So this architecture or system architect will involve in the earlier phase, usually on planning and analysis of our system. So they will bring us, or they will design the architect of our whole system. Okay, so here architects solve problems creatively when they are involved at the earliest planning stage. This one I mentioned just now, earliest planning stage. So usually they will involve in planning and analysis stage in our SDLC, system development life cycle. So they gain more opportunities to understand your business, develop creative solution, and propose ways to reduce cost. Okay, so this is the importance of why they need to join, or why we need this software architecture in earliest stage of our SDLC. Okay, so here, system architecture. So this one that I mentioned just now, system architect. So this system architect is a part. System architect is actually part of our team, development team. No, it's not development team. It's part of our team to develop our system. So here, system architect. But this is very rare actually, system architect. But for some stable business, some stable company, of course, they have this system architect. Okay, but rare. Usually, it will be done by the BA only, BA business analyst. Like I already mentioned to you. So system architect. So it will act on behalf of the client. So client here is referring to the user of our system. Okay, for example, if they want to develop, for example, our um, student intranet. So it will act behalf of the student. The client is the user. So the user is the student or the staff. Okay, based on the system. Okay, and then address the big picture. Okay, why they need to address the big picture, the overall view. They need to address the overall view of our system on how it will be designed or what it should be done. Okay, that's why address the big picture, the overall view, one complete or one whole system. And then ensure ensure that the required qualities of the system are accounted for or in the design. So required qualities, there are a few actually, which we will see later in this slide or in this chapter, which is yeah, required qualities. So of course, when we're designing a system, there are a few qualities that we need to tackle, that we need to take into the account when we design. For example, security, performance, reliability, but that one later. And then solve problem. The problem here is actually referring to the requirement of our system, or what might be the traits, or what might be the possible issue. And then ensure the required features are provided at the right cost. This one features is like, what is the required hardware. For example, the server maybe. This one also we will see in the next slide. Okay, so features is usually what is the features. It can be software, it can be hardware that it needed to develop our system. Okay, So far up to this slide, any question? Can I proceed? Hmm. Jeremiah, question? Oh, okay. Eh, uh, where is? Oh, he's here. Okay, so let's proceed. Okay, here we are on the key definition of system architecture. Okay, so here, system. System is a set of components that accomplish a specific function or set of function. Okay, so what is component? So as you see here, system is a set of components. So that means components or subsystem, which you guys are already familiar and you know already what is subsystem. So components or a subsystem is actually when we combine them, it will build or it will, yeah, it will build a system. So components or subsystem have their own specific function that they need to perform in order to complete or in order to make a system. That means this component, for example, component A have this function, then component B have their own function. So they will combine and they will perform the task or any specific function they need to perform to complete our system. Okay, so system can be actually break into module, which is known as modularization, and components. Okay, so components and subsystem actually have the same function. So they will accomplish and specific function or set of function. Okay, so architecture is the fundamental organization of a system embodied in its components. So their relationship to each other and to environment and the principle guiding in this in its design and evaluation. So as you see here, architecture is actually the, like I mentioned just now, so it is the fundamental of organization on how the components is related to each other, not only to the component between themselves, it can be the environment. So I already explained to you guys what is environment last time. So environment is where we will deploy our system. For example, the server that we will deploy our system. So that one is architecture. And then architectural description. So here I already highlight description. As you can see, description is the documentation of our architecture. So description is a set of product that document the architect. So it is the documentation actually of our architecture, of our architect. Description, so you need a documentation. So the documentation will include this thing. Okay. And then this is a concept that you need to know in software architect. Okay. Actually, this course, software architect, is actually no, this course, yeah, no, this chapter, software architect and system architect, it can be a one or standalone course. Yeah, it can be like OOAD, it can be one standalone course, but I think this is they put in this chapter in, I mean, they put this title as a chapter for this course. So actually, there's a lot to learn about architecture of computer. Okay, so here is the term that you need to know. First is architectural view. Okay, so what is architectural view? So architectural view, it is a representation of a particular system or part of a system from a particular perspective. So what is it mean by this point here? So particular perspective. Um, for example, particular perspective, we see the quality. Let's take example security just now. Quality of our security, because security is crucial when we want to develop a system. So let's take example as security. So how do we think? How do we view? How do we view the security performance or security attribute of our system from a particular perspective? For example, particular perspective, it can be a perspective from a user. Okay, how the user see security, security attribute of that system. So particular part of a system from a particular perspective. That means they're being specific part or specific attribute from a specific perspective. Okay, specific perspective. It can be, for example, is now student. Okay, that one is architectural view. Okay. Oh, by the way, for architectural view, I think I mentioned this too before. In when we're designing a system, okay, we have different point of view. That's mean for once, system is too big. For example, a module, okay, module or a component, we have different perspective of view. For example, let's take ourselves here as a programmer. So for example, we as a programmer, we see things differently from the view of user. Okay, sometimes what the user want is not what we develop, or sometimes what the user want is not what the BA, business analyst, model the diagram, what the BA understand. So that's why we need this subject OOAD. That's why different perspectives sometimes lead to like miscommunication, just because they see things from different perspective. So that's why we need this OOAD to diagram the requirement. So like I mentioned to you guys already, diagram is important. Okay, and then architectural view. Okay, so what is architectural viewpoint? So architectural viewpoint is actually a template that describe how to create and use architectural view. Okay, it is a template that we use to represent this one, represent a particular system or part of system, can be components, can be a module from a particular perspective. So when people say architectural viewpoint, you need to go back to the concept of this. So it is a template that describe how to create and use architectural view. Okay, a viewpoint includes a name, stakeholder, concern addressed by the viewpoint, and the modeling and analytic convention. Okay, here a name. I think this one is straightforward. So stakeholder. So in a software development process, a stakeholder can be those people who are involved in our system development. So for this one stakeholder, I want to ask, what do you think is the example of stakeholder? For example, just now I give the definition of stakeholder. So stakeholder is the people or person that involved in our system development. So Jonathan, who do you think? Again, can you give me one example of stakeholder? Client? Yes, client. Client is referring to the user, like I said just now. Client. So example of stakeholder is our client, customer, investor maybe, but that one is too bigger picture already. So stakeholder can be the client, customer, employee, and investor. Okay, that one is stakeholder, those who are involved in our project. And then concerns addressed by the viewpoint. So actually, when we're developing or we're designing a system, from each I think from stakeholder, they have their concern that they address from the viewpoint. For example, mm, okay, for example, mm, when, okay, this is an example. Last time during my my project when I working last time as a programmer, there's a client, because I'm in banking industry, there's a client that asked to mm, to view the account number of, no, the client is the bank actually. So this bank is actually asked us to develop a system where the system view the account number. No, they want to only view like last 4 digit of the account number of the account holder. For example, I am the account holder, then they want to view my last 4 digit account number. So even though it's only an account number, but for some cases, account number is like, it is too PNC to share with people. So we have this concern, different view or different perspective that we see. The client, which is the bank now, our client is a bank. So the bank want us to show the account number, like I said, last four digit. I don't remember already, but it's like they want to view the account number. But from our perspective as a developer, as a developer of the system, we have our concern. So that's why it is very important to tag all the concerns into the account. That means we need to analyze everything into the accounts. Okay, and then the modeling and analytic conversion. Modeling is the diagram. Analytic conversion is any convention that include your analysis of your requirement. Okay, analytic convention. Okay, here we have four. Here, this one is by this person. So system architecture type. So there are four type that list or adapted from this guy, Sunny et al. Okay, the first one is conceptual, module, code, and execution. So let's look at each of these. So um, conceptual. So example of element is components. Okay, let's look at this first. Example of relationship is the connector. So you know already what is connector. Connector is the, for example, from one component to another component or one subsystem to another subsystem. What is the relationship of them? So we are using connector for components or subsystem. Okay, this one is conceptual. And then module. So like I said, module is in a system. In a system, usually we will break our system, one whole system, we will break into subsystem or module. So this subsystem and this module or component will have their own specific function that they need to perform, function or task they need to perform. And then this is the relationship, export or import. So maybe from this, for example, subsystem A or module A, they need to export their example relationship. Maybe they need to export something into another subsystem or module. This one is example of relationship only, export and import. And then code. I think for your level, you already know what is code. So code is, you know already what is code, okay? C or programming. So code. So example of elements is files, directories, and libraries. Okay, and then example of relationship include and contents. For this one, for code, I want to know here, can anyone give me example what is a library in that you usually use in your code, since we are on this subject now? So here code, here is file, directory, and libraries, include and content. So how do you apply this? What is library actually? Student, what is library? What is library? This is an example Java library. Okay, so okay, before the client. Okay, so this one is the starting. Okay, library is actually where we keep the store function. Okay, for example here, yeah, the string include like that. Yeah, this is example of library. Library maths Java lib. Okay, so what is library? This one in programming actually. By the way, library is where we store our, there are two type of function. First is built-in function. Built-in function and self-defined function. Okay, so built-in function is actually the function that already created and we store in our library. Where is it now? We already stored in our library. Okay, so for example here, this one is by Noel. So for example, under maths library, what function do we have? For example, we want to calculate the square root of our input, maybe input or number. So the square root is already stored in library. So that is the function of library. Okay, include. So, oh, sorry. So So you can see here include or content. That means the function is already stored in library. Okay, that one is for built-in function. But since you already know you guys already learned programming, so you know that there are some function already built in the libraries, and there are some function that we need to define. We need to create on our own. Okay, and then this one is execution. Okay, execution, the component is task, threads, object, interaction. So example of relationship, use, and call. So execution is actually a process where we will run. No, it's not we will run. We will execute, we will conduct, we will run. I think you know what is run, right, for programming. So we will execute, yeah. We will perform. We'll perform the task. Yeah, it's like performing. Execution is run, perform, the task, threads, objects, interaction. So this is the sample of relationship, use or call. Okay, so this is the system architecture type. Okay, from this slide, any question before I move on to the next slide? Celine, do you have any questions, Celine? Is Celine here? Oh yeah, she's here. Okay, so let's proceed. Okay, so you need to remember the type of module, but this one is actually adapted from this guy, conceptual model code and execution. Okay, this one is the explanation based on the type just now. So the first one is conceptual architecture. So conceptual architecture is actually concerned with the structure of the static class model and the connection between the components of the model. So here, what is static class? So static class is a class that cannot be inherited. So we already covered what is inheritance, right? We already covered in the previous chapter what is inheritance. So static class is a class that we cannot inherit. Okay, so it is a class that we cannot inherit, and then the connection between the components of the model. Connection here can be the relationship or the association. How does this class, or how does the class is related to each other? It can be between the components, or like I said, components, subclass or object. Okay, components of the model. That one for conceptual structure of the static class, and then module architecture. So module, already mentioned few times already, module is the sub function of our whole system. Okay, so it is described the way the system is divided into subsystem or module, and they communicate by exporting and importing data. Okay, this one, for example, we have eh, too many. I think 3 is enough. Uh, yes. Mm. So you can see, right, my screen. So this is not a proper diagram. However, this is the explanation on this one, module architecture. So describe the way the system is divided into subsystem or modules, and they communicated. They communicated by exporting and importing data. So here is actually an example of a system, how we do the modularization, or we breaking this system A, one complete or one full system, we break into sub. Oh, actually, this one is B. Sorry. We break the system A into subsystem A, subsystem B, and subsystem C. So this subsystem actually they have their own specific function. They have their own specific task to perform. Okay, and then here they set by exporting and importing data. So this one is the example of the association. If you slide back to our previous slide, exporting and importing data. So this is the way that they communicate to each other. Okay, by exporting and importing data. Okay, this one is for module architecture. Next is code. Okay, code architecture. So defines how the program code is organized into files, folders, and group into libraries. How our program or how our program will group, because they need to group. For example, here just now I asked what is example of library, right? So here the common one, maths library. So in maths library, maths library is the common one, but actually there are a few more. But let's use this for an example. So okay, let's take maths library. So code architecture is actually how program code is organized into file, folder, and group into library. Okay, maths library. So in maths library, we cannot combine the maths function with the library with other, for example, maths. So they only perform anything that already defined under the library that will only perform some mathematic function. We cannot combine any other function that is not related to mathematics under the maths function or maths library. Okay, they need to group into their respective library. Okay, they cannot combine in one library. Then next is execution architecture. So execution, like I said, is where we run or where we perform, where we conduct. So it is an architecture that focuses on the dynamic aspect of the system and the communication between component as task and operation execute. So what is dynamic components? Just now I mentioned about the static components. Okay, now is dynamic components. So components that for dynamic aspect or dynamic, where is it just now? Oh, this one. So dynamic aspect, or we call as dynamic component, it is actually a component where it does not have a defined location. Instead, it will change, it will only be placed in the application at the runtime. This one is, yeah, that's mean they don't have a specific component location. It will only have the location, component's location during its runtime. Okay, I think no, dynamic sub is actually not only for this one, not only for this concept. However, dynamic is something that is not static. That means it will keep on changing. Okay, so that's how we apply into dynamic components. That means they don't have a specific or they don't have a fixed location in our application. Any question? Sorry, this guy. Daniel, do you have question? Alvin? Daniel or Alvin? No question. Oh, Alvin, I have a question. I think it's Alvin. I WhatsApp him last night. It's between Alvin and Daniel. I don't remember. I think Alvin could. Alvin, I asked him regarding this one is related to RM, the questionnaire. Then I'm not sure if that is a short form. I'm not up to that with short form. You're saying yo. So yo is what actually? I want to ask you, but it's too late already. What is yo referring to? Is it yes? Let me open back. Ah, I asked him the questionnaire, how many already? Yo, 36 people. Yo, is it like yes or yo. What is YO stand for? Is it yes or you said like yo, what's up? If yes, then that's okay. If not, tell me what is the short form stand for. YO. By the way, since no question, can we move to system architecture as a view? As a view is system architecture's view. So let's not a sure. Okay. Okay, then thank you, Alvin. So here 1, 2, 3, 4, 5, 6. Here, as you can see, Krachen's RUP's 4 plus 1 view. Okay, why 4 plus 1 view? In the next slide, it will explain why 4 plus 1, why not 5. Okay, so here we have this use case view. So you know already what is use case. Use case is, I think, one of the use case diagram is one of the earliest diagram that we learn for this course, use case view. So what is the view or what is the system architecture view from use case? So here the important use case in the system and scenarios that describe architecturally significant behavior. Okay, so use case usually is the, I won't say fundamentals, but use case diagram or use case view usually is the basic of our diagram or our system architecture. Okay, and then logical view, important design classes and interfaces in a package structure with composite structure diagram. So this one is how we connect them. What is the logical flow of our system? This logical, when you go to work later, I think you will heard this term. What is the logic of the system? What is the logic of the system? What is the logic of the process? Okay, this logic term is not something that I can tell we cannot learn from our slide or we cannot learn from our school. I mean your school, yeah. School is us. I mean school. So this term is not something that we cannot learn. So how to capture this one is only by, I can say, experience. Okay, different company have different logic on their system. So this one is logical view, important design classes and interfaces in a package structure. So package is like grouping together. Okay, grouping together with composite structure diagram. Okay, so here is another diagram. So what is composite structure diagram? Wait, I think my it's too bright. Okay, what is structure diagram? So structure diagram is actually a diagram that contain this thing: interface, interface package. So it is a diagram that show what is the relationship between the interface and the package. And then implementation view. So implementation view, architectural decision made for the implementation in terms of subsystem and components and relationship among them. Okay, the implementation of these sub and components and how do they related or how they associate with each other. And then process view, a description of the process or as process and threads and inter-process communication. So inter-process communication. So guys, what do you think is inter-process communication? Alvin, what is inter-process communication? What do you think? What is this? Inter-process. It's not him. Ferry Vincent, what is inter? What do you think inter? Concan Sharp, what is inter? Here, inside, there's keyword. There's a keyword. It's okay, Ferry Vincent. There's a keyword here, inside. So it is actually when there is a term inter. Hey, oh, okay. When there is a term inter, that means it's only happen inside. Okay, inter-process communication. So inter is only like Alvin said, sorry, inside the group. Okay, communication using stereotype classes. So inside the classes, communication between them. And then deployment view. Okay, physical nodes for the likely deployment platform components deployed on the nodes and the communication channels between them using deployment diagram. So, anyone know what is deployment? Can anyone tell me, is there anyone know what is deployment? Rachel, what do you think? What is deployment? Russell, sorry. Russell, what is deployment? Ivan, what is deployment? Okay, sorry. Okay. Development, testing, client. Deployment is actually is a system. I don't think you study programming. Yes, you study programming and you study database as well. That's true. But what is the relationship? So here, this one is uh one is not a proper diagram, but this one is the flow only. Okay, not a proper diagram. Okay, so okay, for deployment actually system going live. I'm impressed. How do you know this term? No. Wait, Kelvin Shark. No. Going live. Okay. I explain my term first before we go to going live. What is going live? Maybe some of you do not know. Okay, what is deployment? My question just now, what is deployment? So I don't think you learn this in any subject. However, this is the process. Okay. This one is the development where we do our coding, where we write our coding. Okay. This one is programmer, us, software engineer or QC or this one is can be a VA. What what support team. Okay, sorry for my bad diagram. However, here is the process. The developer will write a code. They will do the coding. They will write the code. So this phase after they already finished this step is development. This one is development. They will send to QC. Like I already said, programmer cannot pass their own software or their own part because that is biased. So they need to send for testing or QC. QC is actually a quality check or a tester. So this tester will conduct a test based on the requirement. Yeah, they will cross check whatever they sent by the programmer. Okay, so assuming that whatever the developer already done is correct and it is already fulfilled the requirement, they need to deploy. So the term just now is deploy. So what is deployment? Deployment is actually a process where we will move because in when we're developing when we're writing our code, usually we will only write the code into our local is our PC. So deployment is actually a process where we transfer our system into the environment. Environment, here, server. Oh, sorry, server. Okay, server. So where we transfer our product system into the server. That is deployment. We put into the server. Okay, that is deployment. However, there's one term, going live. Kelvin Shark, what do you understand with going live? What is it by going live? What is going live? Since you already know the term. Mm-mm. So actually, going live is a process where we actually going live. Sorry, actually going live is a process where we let the user use our system or product. So that is going live. However, deployment is different when you with going live. Why? Because sometimes, for example, let's go back to here. For example, for banking, because banking is very crucial. So not only one server, they have, I think they have 3 server. That's mean this is us, this is me. No, I never deploy actually because I'm not support team. So yeah, so they will deploy into a server. Going live is actually a server that's too deep. I mean, going live is a process where the user will use their product or a software, but don't mix going live with deploy. Sometimes when they say deploy, it can be they have different server. So when people say going live or deploy, it is not the same thing. That's mean going live is go to the user. Deploy is only a process where we transfer the product or the software into the server. Okay, the server is not necessary the production server. There are few level of server. Okay, if suddenly, can you imagine suddenly, for example, if suddenly this is our tester and then they want to deploy, what if the environment is what if whatever we deploy then suddenly have problem? That's why they have like few more layer of server before they really deploy into the production server. Production server is this one. Okay, this one going live. This one will include the production server. Deploying the system for use. Yeah, so that's different actually. Where did you know that term, Kelvin Shark? Where did you learn that? Games. Good. Then whatever you doing, then that's good. Okay. So here just now is deployment already. Deployment view. Physical node. Physical node is, we will see later in this lecture, for likely deployment platform components deploy on the nodes and the communication channels between them using deployment diagram. Okay, node will usually represent the hardware, what we need. Okay, what the physical hardware, maybe physical server. It's an example of node later. So here, system architecture, why we need to use it, why we need to model it. Okay, first, architect use models to reason about the system and its ability to deliver the required quality attributes such as um, reliability, performance, security. Okay, this is the attribute aspect. Other than this one, reliability, performance, security, modifiability, it's another example too. So particular views help to reason about particular attribute. This one is the thing I mentioned early of this chapter. Okay, quality attributes. That's mean from particular view we see things. I mean from particular view, how we see things on that particular attribute, any of this attribute. Okay, for example, uh, how the user see the performance attribute, or how we as the programmer developer see this security attribute. Okay, specific. So this is the one, I won't explain this diagram because this is the one I explained just now on use case. This diagram is same with page 9 just now. 4+1 view. That's why it said 4+1. Okay, this one is the same with the patch 9. Just now I explained use case, logical implementation, process deployment. However, what's important is this thing, not the 4+1, but the here, this 5 element. Okay, 1, 2, 3. Yeah, the same one with patch 9 just now. Okay, so any question before I move to ADL? Wang Zisheng. Is there any question, Wang Zisheng? Oh, okay. Then what is ADL? So as you can see here, ADL is architecture description language. But what is architecture description language? So ADL is actually a language that use graphical or textual, or it can be both. So it can be graphical or textual or both to describe the software system in terms of its architecture. Okay, so that's one is ADL, language that use graphical or textual. Okay, ADL UML 2.0 adds or change feature to support modeling architecture. So this is actually a version. I think you know this already. It's not only software. It can be game. For example, they have version. So of course they have something that they change, or it's not necessarily a change. It can be a bug fix. But of course, there's something different with the version. So here UML 2.0 adds or change feature to support modeling architecture. Okay, and then this package diagram. Package diagram, like I said, package is like we are grouping together diagram. And then component diagram, the sub when we are breaking. When we're breaking, I mean the system, when we break the system into components, module, or subsystem. And then composite structure diagram. Composite structure diagram is a diagram that contain class, interface, package, and what is the relationship. And then deployment diagram. Deployment diagram is how we execute, how we run them. So we will see 1, 2, 3, 4 this diagram. Okay. Here is the system architect. What influence the system architecture? First, existing system. Okay, of course, existing system will affect our new system in terms of it's not only architect, it can be the whole system, how it will be different from our current existing system. And then here, enterprise architecture and technical reference architecture. Okay, technical architecture is actually a component. Yeah, technical reference architecture is actually a diagram where the components in a system, this one is actually for large view on how our components interact, associate, related with other. Okay, so this one is from the previous slide just now. Okay, we will go into each of this. So just now, existing standard, existing system. Sorry. So existing standard, existing system, which is standard architecture. So like I said, what is the difference with the existing or current system that we already have? What is the standard of the architecture? And then heritage system. This one may be wrapped using adapter. Guys, what is adapter? Yeah, what is adapter? Daniel, what is adapter? What do you think? Who else I haven't asked? Ivan, what is adapter? What do you think? What is adapter? What is adapter? No. No, no. What is adapter, guys? Para Vincent, what is adapter? Konkenshak, what is adapter? Example of adapter. By the way, it is here in this context, it is actually referring to a connector. Okay, maybe wrap using connector, and then service wrapping system with connector. Okay, and then we have this term here we call as MDA. Okay, MDA is not stated here in this sample, but MDA, okay, MDA is actually this one, page 14. MDA is actually stand for model driven architecture. Okay, so MDA, there's two terms that bind with MDA. If you go to Google, this term PSM and PIM, these two terms will bind with MDA. So what is MDA? MDA is actually an approach for software design and software implementation. So it is an approach for software design. So like I said, for this MDA, we have these two terms, PSM and PIM, platform specific models and platform independent models. So what is PIM and what is PSM? This one is quite easy actually. So PIM is an independent here. PIM is an independent of the technological platform used to implement. That means it is independent platform for PIMS. And then we have PSM. PSM is in PSM is actually it is a framework conceptual structure intended to serve as a support or a guide. Okay, so they have their own specific function, but this one I think it is not something that complicated. If you go Google, there's nothing much information about this because this one is not, it's like a concept only under MDA, model driven architecture. Okay, and then reverse engineering existing system logic using PIMS. Okay, so we have reverse engineering here using MDNA and MDNA. This one is actually an approach in our system development. Second is enterprise architecture. So as you can see here, pressure in the US, there's an act here. This one is actually more to, it's not low, but yeah, it's an act. It's like, what's act? I mean, it's like an act. Okay, this one is actually why they have this architecture. If you go to Google, of course there's some event, but I don't think that's important. But yeah, you can go and Google these two act 1996 and 2003 due to pressure in the US. And then framework. So what is framework? Framework is actually like a guide when we want to develop or when we want to design a system. Not only system, it can be game. For example, if you want to develop game, we have a framework. So framework is like the guideline that we need to follow. A guide. What, for example, okay, take system. So what is needed for a system to be called as a system? So this one is a framework, a guide. Yeah, guide that we need to follow. So here is the example of framework: Federal Enterprise Architecture Framework, Standard and Architecture for E-Government Application, and Zachman Framework. So this is the example of our guideline that we need to follow when we are developing a particular framework. Okay. Next is number 3 here, technical reference architecture. So it is a standard for technologies to apply. So yeah, it is standard. And then guidance on to apply them. This one is something like framework just now. Oh yeah, this one. It's example here. So guidance on how to apply them. For example, system. So it is a system. How do we apply? How do we develop a system? So this one is the example of framework. The open group architecture framework, architecture, development method, enterprise continuum, and resources. So it is how we want to develop, okay, how we want to develop our software or our system. So that one is framework. So actually, oh yeah, you will, heard this term a lot, framework. So that one is for system architecture. Any question before I move on to architectural style? Wong, this Wong, Nyapa Wong, any question? Okay. Hmm. So I think we can move to the next question. Next question. So next lecture. Okay. Oh, sorry. So let's move to the architectural style under system architecture. So this style, architectural style, is actually applied to physical architecture and software architecture. So anyone can give me example what is physical architecture? What is physical? I mean, how do I ask this? Hardware. Yes. What is the hardware that you think needed for a software or a system? What? Server. Yeah. Physical networking. Okay. Hardware. Yeah. Hardware. Server. So server you need to stat as physical server because server have two, cloud server and physical server. Physical server is the thing that the server, the physical server. So if people ask you, you need to state either it is cloud or physical. Cloud is something that we cannot see. Physical server is the thing that is hardware. Okay, physical. Networking, I don't think networking is as hardware. This one, yeah. This one is maybe related. So you know already. Server cable. Yeah, yeah, yeah. Okay, Russell. Hmm. So that one is example. So apply physical and software architecture. You know what is software. So this guy, Bass et al., identify five main type. So since here we already on this subject, et al. Is referring to the writer or to the writer or the founder of the idea. So et al. Referring to more than one person. So these people, not person, these people identify the five main type, which is independent components, data flow, data centered, visual machine, call and return. Okay. So this one is only the type that is five main type that is list that is identified by these people. So independent components, single or individual components, data flow, the process, data centered, visual machine, call and return function. Okay, only that part only. So here is our review question. Mm, Review question discuss MDA. MDA, this one is okay. There's two. MDA discuss MDA and discuss platform specific models. Just now, PSM and PIM. So this PSM and PIM is bind under MDA. So this one is you can refer this to page number 14. Okay, this one you can refer to page number 14. So MDA is model driven architecture. It is a software approach. Software of yeah. Is it? Yeah, approach in our software design, development, and implementation. Okay, so now this is where we will start our diagram, but it's more to concept actually. But before we proceed this, I want to take water actually. Can we have like 5 minutes until 11:15? Okay, thank you guys. So, hi guys, welcome back. Not to my YouTube channel, but to our lecture. Okay, can I proceed? Yes. So here is package diagram. I think just now, oh yeah, this one is, there are four diagram actually: package diagram, component diagram, structure or composite structure diagram, and deployment diagram. So first we will look into package diagram. So package diagram is actually a structural diagram that used to show the organization and arrangement of various model elements in the form of package. So if you think that's too long for you to understand the concept, so package diagram is a diagram that shows the general construct of a group unit together, which is
I
package.
missed the
So right,
presentation.
I already explained present. Mm, okay, I repeat. So here, package diagram, I repeat. So here is the one is package diagram. So there are few diagram more. So we will look into the first one, which is our package diagram. So package diagram is a structural diagram used to show the organization and arrangement of various model element in the form of package. However, I think that is too long to capture the concept. So package diagram here is here general construct that group units together, or we call as package. So like you already know, package is like we grouping together. Okay, we grouping together. They have the same. Usually we group together in a package based on the same attribute. That means they have something in common. Something in common. Okay, for package. Used to reduce complexity of models. Okay, why we can reduce the complexity of models is because first, we already group them in the same, like I said, common. Usually they have some common attribute. So it can reduce the complexity. And then a package diagram shows only the package. It doesn't shows the single or individual element. It will show one group as a group, one group as a group only. Dependency relationship represents a dependency between package. That means whatever the relationship, it will based on the package, one group, not individual group. So here is the example of package diagram. So dependency relationship, package A and package B. What is the dependency? What is the relationship between this package? The thing, because in package, of course, we have our element object already we package together. So this is one package and then this is one package. Okay, so we see what is the relationship or what is the dependency between this package. So this is the diagram or example of dependency relationship. Okay, so how to build or how to come out or how to model this diagram is, okay, how to model this package diagram is set the context. Okay, set the context of our diagram, and then cluster classes together based on shared relationship or mutual or common attribute that they have. Cluster class together, that means we like group them together based on the mutual or shared relationship. And then model cluster classes as a package. This one already grouped together. Okay, we combine this clustered class, the thing I said just now, classes or our element, we combine together as a package, as a group that have the same attribute or same, they have something in common usually. And then identify the dependency relationship among package. We need to know which package is related, which package is associated. And then place dependency relationship. Dependency relationship between package is referring to this notation, arrow. dot, no, dot arrow. Yeah, this arrow actually. So that one is dependency relationship between the package. There's no package A and package B. Okay. Okay. So package grouping of modeling elements. So just know what is package. So package is a grouping of modeling elements. That means we are grouping together. So like subsystem, each service are the result of the service by its classes. That means, like I said, or like from this slide, under package we have, or in, sorry, in package that we have combined, or we have the classes that we group together. So like subsystem, the service are the result of the service provided by the individual classes. Okay. Subsystem encapsulate some part of system behavior. Encapsulate also referring to the meaning of grouping together. This one already covered on chapter 1 or 2. I don't remember, but encapsulate like we are grouping together in one thing, in one package. So some part of system behavior. And each service are the results of the service provided by each class. Same with this package on the second point of package here. Check this one, check this two. Okay. Service provided by its classes. Okay. So the difference between subsystem and package is that for a package, a client adds some element inside the package to fulfill the behavior. But for however, for subsystem, a client asks the subsystem to fulfill, or subsystem itself to fulfill the behavior. Okay, so this is the difference. I highlight here. I highlight here this one. Okay, difference between subsystem and a package. So this one is the package. As you can see here. Okay, subsystem and package. Okay, subsystem. Okay, we have two diagram here. Subsystem and a package. ID subsystem package. This one is subsystem. This one is our package. So this one is for financial transaction. Okay, as you can see here, we have financial transaction payment and financial transaction receipt. So each of these objects here have their own specific function that they need to perform. So this one, maybe just a guess, financial transaction payment, they will do the transaction of payment. This one, maybe they will produce or they will return a transaction receipt. Okay, this one is for subsystem. However, this one is for package. Okay, so this one we will implement and we will use the package to come out with a financial interface. Financial, finance, finance interface. Okay, so this is how they link together or how they work together. Okay, this one, as you can see, this is abstract window toolkit for the relationship. So adaptability abstract windows toolkit, as you can see here. There's an explanation actually. Oh no, no, they don't have. So this is actually they already combined together for system and subsystem and package actually for adaptability abstract window toolkit. Okay, this is the relationship. Other capture UI, they have a relationship with this package AWT Java GUI. Oh, okay. Guys, what is GUI? Package only have GUI. Depends on the application maybe. Package only have GUI, graphic user interface. Yeah, what is GUI? What is graphic user interface? What is the function of GUI? Package only have GUI. just menu. GUI interface. Okay, first, graphic user interface. GUI stand for graphical user interface. So GUI is actually it is an interface that we need to communicate with the interface using a device. Okay, we need to communicate using a device. Interface that we are the user, we need to communicate using a device. For example, game. Let's take game as an example. Joystick. You know what is? I think you know what is joystick, right? Controller, joystick, controller, something. So we communicate or play the game. We interact with the interface using that controller, joystick. Is it the correct term? I'm using joystick. I'm not sure, but yeah, that's the example. We need a device. Package only have GUI. No, it depends. Yeah, for the user. Can click icon. Icon, click icon. GUI for the user interaction. For the operate. For user operate system through graphic. This one is GUI, right? Yeah, so GUI is actually a user interface through which the we as a user, yeah, like I said just now, there's a device that we need to use or something that we need to use to interact with our system interface. Okay, that is GUI actually, graphic user interface. Yeah, mailing list. Okay, so this is the example between the subsystem and the package relationship or association. Okay, I want to highlight this thing because I think this is too common, not only for student. Each this dot, this is not dot, this error, this dot error is not same with this error. The one, this one. Oh no, this one. One straight or solid error. Okay, don't use different error. So if you write, then the association or relationship is wrong already because you slide back on the previous slide. It's already set there. So this one is the example of overview of, it's not overview, like this now we have an example, but this now it's only between two. So now we have the whole system, okay, how they interact. Hmm. So subsystem and package, nested package. So you already know what is nested. So package may have relationship with other package to show that dependencies are between package. Okay, dependency relationship to show how the package is dependent on each other. Okay, so this one is only like a concept. So package may have relationship with other package. Yeah, it is the association or relation between package to package. So, so, so to show that dependencies are between the package, that means they need dependencies between the package. That means they have association. They have a function that they need to perform to another function, or this package will affect this package. Okay. So dependency relationship are used to show how packages are dependent on each other. That means, yeah, the explanation is repeating. That means they show how dependent or how the package is related or associated with each other. Next, we have component diagram. So before we move to component diagram, can I move to component diagram? So what is component diagram? So component diagram is describe the organization of the physical components of a system. So here, component diagram are different in terms of nature and behavior. So it is used to model the, this one I mentioned just now, physical components of a system, physical artifact of a system. So components diagram are used to describe the the physical artifacts of a system. So this artifact include file, executable, libraries, package, etc. Etc. So this is a component. Here is an example for component diagram. So in the UML, a component is graphical represent as this one. So this is the notation, or maybe we can call as a symbol for a component. So a component is a graphical represent as this one. So this one is our, okay. So this is the example. Well, this one is the proper one actually. So this component is related to this component. So you need to know two things here. First, this is the graphical, graphical or the symbol to refer or referring to our component. This one is the dependency relationship. That means this component dependent on this component, or this component is dependent on this component. That means these two components are dependent on each other. Okay. So in the UML, a component is, like I said just now, a component is graphical represent as this one, kernel. Kernel. This one is a example of component. So as you can see here, there's a component for payment. So here they didn't state what is the component. It can be maybe this now the client, the supplier, right? Yeah. So client or supplier. So my point here is this is referring to a component for this payment process. Okay. So your component is a payment. Component is a payment. Oh no, I take back what I said just now. Instead of doing this, why they didn't state something like payment inside? So yeah, component payment. So the component is a payment. So here is the graphical representation. I think this one is enough. The point is here, the graphical representation of a component is using this one. Okay, and this one is the relationship. So this one is actually the same but different component. So component diagram. So component diagram does not describe the function. It won't show what is the function of the system, but it will describe the components used to make those functionalities, what it is built or what it is needed to perform the function. It won't show what is the function of our system. Yeah. It shows what it is need or what it is need for the system. So from that point, components diagram are used to visualize the physical artifacts such as this now library, package, file, etc. in a system. What it is needed, this one it is what needed. I mean this thing is what needed to perform or to make the functionalities of our system. So components diagram can be described as static implementation of a view. Static implementation represent the organization of the components at a particular moment. Okay, so that is component diagram. So for component diagram, we need to know it won't shows what is the function of our system. Instead, it will show what is the component that will perform the function. And then component diagram, the usage of component diagram is, of course, the component. What is the component of our system? DB schema, executable of an application, and system source code. Okay, this one is, so back to the concept of component diagram, it won't show the functionality, but it will show how to perform. So this one is how we can perform the function of our system. Okay, so this is the example actually, component diagram, example of interface. So this one is video store, and we have this component, receipt generator, card verifier, and payment. Okay. Oh, okay. So this is the relationship association component. Oh, salah. Receipt generator and payment. So the interface is check number of digits, check leading digits, and check sum. Okay, so this is a process actually to no. This is a component diagram that show what is the component needed to perform one function. Reimbursement, pay acceptance. Yeah. So this is the example on how we okay, my bad just now. So this is the component, and then this is component that related to this payment component, and this is the function. I assume you know how to read this thing. Check number of digit, leading digits, and check sum. Okay, this is the example of interface of video store. Okay, by the way, what is no, okay, I think you know what is Boolean. Okay, so that is the example of component diagram for video store. And then we have another example for online bookstore. One, I want to ask, how many components do we have here? How many? One or none? Or how many components here in this patch, in this example for bookstore online? Mm, yeah, five. HTML, HTML, exe, table, and table. Okay, this is the component that needed for the patch, patch executable, table, and table. Okay, so this is the component. So this component A, front.html, is related or associate or dependent on this search HTML. Same goes to this to this too. Okay, this one is the association, the relationship. So this is actually the process from the previous slide just now, the bookstore online bookstore. So example of a component diagram of the online bookstore that use a standard notation or a component label with stereotype. Okay, the diagram shows this is the explanation of the flow. So first the customer moved from home to the search page. Home, which is home is the front landing page or home, front page or the landing page. So this three things is the same. It is the page that when we, for example, when we go to the landing page, the page that once you search that page, what is the first interface, what is the first page. So that one is the front home page to the search page. Okay, when she or he defines some search criteria and asks the system to proceed, the search program will take over. This one already key in the input, so this one will take over. They will execute whatever they already key in from this patch search.html. So the program will search on the book table or the table or both depending on the criteria specified by the customer. This one on the split one just now. Just to based on the book or based on the author of the book. Okay, so that one is the example of online bookstore. So in the UML, a component, this one is same with the previous slide. So in the UML component graphical represent as this one. Okay, this one actually. So it's repeated. Okay. So that one is on component diagram. And then we move to deployment diagram. Any question on component diagram just now? Leave. So let's move to the next slide, deployment. So deployment diagram shows a collection of nodes. Node is the physical attribute or physical hardware, and also the dependency association among those nodes. Okay, so this one I think, yeah, there's an example. Okay, so node is actually the physical physical hardware. And then on a deployment diagram, an association between the represent physical connection. Okay, so deployment diagram, it shows the relationship between the physical node. Okay, the UML deployment diagram provide a picture of how the physical system of, for example, how our maybe server and our PC, how it will look when we put them together in a diagram. Okay, there is an example. So a system consists of nodes represented by a cube with line connecting them called connection. Same with the previous one. The line, the association is called as connection. What is the connection between this physical or this node to this node? Okay, so there are two types of node, processor and device. Processor is execute component and device interface with the real world. There's a diagram there later shows the example. So deployment diagrams are also useful for modeling network. This deployment diagram, usually we will see or you will see, and I already touch this, already I'm involved with this one too. So usually it more to network. It's not more to networking, but yeah, it is usually useful to show them. Okay, usually networking student, they are very familiar with this. So deployment diagram, like I said, deployment show what is the connection between the node or physical device, physical hardware. And then deployment diagram are mainly used by system engineer and describe the physical components. This one I mentioned, physical components, you know already what is the example, and their distribution and association. Association again refer to the relationship. Okay, so deployment diagram specify the physical. So this is the concept. Same with the concept of deployment diagram. Specify the physical hardware on which the software which the software system will execute and specify how the software deployed on that particular hardware. So to meet this requirement, hardware components should be designed efficiently and it cost effectively way. Software applications can be standalone, web-based, distributed, mainframe, and many more. So it is very important to design the hardware and components efficiently. So class, what is standalone? Since it's mentioned here, what is standalone software? What is, oh no, yeah, what is standalone software? Jeremiah, but yeah, Alvin, thank you. So it is independent. That's mean from the term, it is standalone, independent. They doesn't need I won't say that doesn't need plug-in. Sometimes plug-in is necessary to complete the system. However, it is they can perform their own function with it, the support without the support from other systems. So it is independent. Web-based, I think you know, distributed, mainframe-based, and many more. Okay, so that is the concept of deployment diagram. So here, the usage of deployment diagram can be, this one is the usage. So to model the hardware topology. There's a slide later, hardware topology. Hardware details for client server system. Client server system, I think last week, client server and peer-to-peer, I explained what is the relationship. Model, last week, I don't remember, it's last week or the week before. And then the model hardware details of a distributed system and forward and reverse engineering. So this is the function, or this is the use of deployment diagram. So before we see the whole diagram, let's look at the notation symbol. So nodes, like I said, nodes is referring somewhere, just now I mentioned about nodes. So nodes in the deployment diagram referring to hardware. Okay, hardware in the model or in our system, what's needed. And then artifact. So artifacts are deployed on the nodes. Example, source file, executable file, db, table, etc. And this one is the common one. Association, link between the nodes of the network. So association between the hardware, how server is related to our PC maybe. Okay, so this is the node. So this is the example. when we combine together. Okay, so like I said, not here as you, oh, I cannot highlight diagram. Okay, so here not is referring, okay, so for this particular not, what is the not for this, yeah, what is the not for this one? Concanshack. Sorry. Concanshack, what is the not for this one? What is not, or what is the not referring to on this one? Alvin. Daniel, where is Daniel? So Daniel, what is not is referring to the physical hardware. So what do you think? What is the not for this one? Yes, I take the first answer. Device, Windows and Linux. Linux is a software. Software. I think you know what is Linux. Linux is OS. So here we have to not device, which is our device hardware, Windows PC and Linux PC. And then this one is the association. Okay, association, and as you can see, there's a multiplicity. So here is the example on this part actually. So here deployment diagram, the notation, a node. So a node is, here is a computational resources, example client, computer server, separate node, or in the device. Okay, so just now I said why, because there's a term here, device. This one too, device. So it is this slide. So it is any device. I think you know many more. I think you know this one too. So it is a device. Is labeled by its name. So the physical, the name of the physical way, and may contain a stereotype to specifically label the type of a node being represented. Example, device, workstation, application, mobile device. For example, here, this is the example. Okay, how we write our node. So mobile phone, this is the example actually. Device, Windows PC. Okay, personal computer. So this one, if you apply, you can go back to the previous slide. Okay, deployment diagram notation. What is artifact? Okay, so artifact is a specification of a software or DB. The specific, yeah, the specific DB, for example, in our DB we have this table, customer table, or other example is student name table, student ID table. Okay, so it is specific name of the, it is pointing to the specific DB. It is pointing to the, I feel like earthquake. No. So actually artifact is referring to a uh specific name, or I mean artifact referring to the specific table in our DB. Okay. So a table or view of database software component. That means they're being specific. So it is labeled by its name, and it may contain a stereotype to a specifically labeled type artifact. Example, source file, DB, and executable file. So here, what is source file? Student, what is source file? What is source file? Noel, what is source file, Noel? What is source file? Source file is actually, okay, there's two terms, source file and object file. Source file is the code. Object file is the product of our source file. Source file, for example, your code. Okay, so it can be specific on this one. So this one is the artifact. And then again on the notation, so a node with an artifact portrays an artifact being placed in a physical node. This one is the from the previous slide. So here is, it's not from the previous slide, but the application, yeah. the application you can apply, or the overall you can see from the previous slide. So this one is artifact. How do we put this artifact into this physical node? So our artifact here is referring to specific customer.xml in the DB server. Okay, so support modeling distribution of software over a network. Okay, so again, stereotype of our communication path, we are using this node for association. So allow nodes to extend message. So again, they are using message passing. I already explained, I already asked in the class how they communicate using object. Usually we have a message passing process. So they're using message. So it may contain stereotype to specifically label the type of communication path. For example, LAN, Internet, Serial, Parallel, etc. What is LAN stand for? What is LAN? Oh yeah, code just now. What source code? Yeah, local area LAL, local area network. Yes, it is a local area network. LAN is local area network. Okay, so this is an example. So an example of style of UML deployment diagram. So like I said, deployment diagram shows the hardware, physical hardware, yeah. Often referred as a network diagram. So if you study networking, do you have a network subject, networking subject? Do you have? See? So I think you should know this thing too better. Okay? So topology or technical architecture diagram. Okay, so this one is an example. So mobile PC hardware. Okay, what is firewall? MBS mainframe passing data warehouse, operational data base application. So what is firewall? Anyone? What is firewall? Security system. Yeah, it is. The concept is true. Firewall is a security system actually to block. It's not to block, but yeah, it's like to block, to protect our data, data security. Okay, so deployment diagram with components example. So this is the overall view on the using of the node. So here we have artifact. We deploy this into our client machine. Client machine here can be considered as a server or DB. So here application server, this big node here, under this big node we have this one, component model payment, model receipt generator, model card verifier. Okay, and then this one is the node. We deploy this artifact into this DB. Same goes to this one. And you can see the association, the use of notation here, the dot line and this solid straight line. And then, wow, deployment with components. So, example, a deployment diagram for internet bookstore. So, this diagram shows physical element. Okay, physical element. This one, this one, this one, this one, this one. Okay, physical element of the bookstore system use variation of the standard client server approach. So you know what is client server approach already. So with the various instance of the web browser representing the client. Okay. In this case, the user defined icons clearly add visual appears and add in understanding the diagram. So here from this diagram, we know what is the component or what is the component needed to perform the function or complete function of bookstore. So here we need a laptop server, inventory server again, and then it will connect with an internet. So this internet will spread or will display or return the result from whatever they get here to this browser. Okay. So that is the concept of deployment diagram just now. So this is the summary of our diagram. So the use case model. Actually, if you read this one, use case model, activity model, class line, class modeling, interaction modeling is not covered in this chapter. However, they mentioned this one is already covered in the few, because here UML diagram. So it's already covered in a few chapter. So state machine, and then this one only, component diagram and deployment diagram as tools for architectural and structural modeling of physical implementation of the system. Okay, some of the model, like I said, we didn't cover in this chapter, so I won't touch on 1, 2, 3, 4, 5 maybe. Yeah, I won't touch on this. I won't go because we already covered in the previous chapter. So UML, this one is only diagram, I mean part of diagram that we already touched, component and deployment diagram. Okay, so in this chapter we already learned about what it is a system architecture, or how we apply, or what is the application, or why we even need them in our project, the views of system architecture, why we need to model the architecture of a system, and the factors that influence the design of a new system. So for this example, we have two exercise. So the first one, I think you can read. However, here I already highlight for my use, for my own use. So they asked to draw a deployment diagram. So this deployment diagram should include this thing, for meal ordering system. And then this one, exercise 3, we need to draw again a deployment diagram for the home computer system that include this hardware. So last week I think Jonathan Ian respond to me, because last week he mentioned that we have few chapter that we haven't covered the exercise. I'm aware there are 2 chapter, 3 exercise, chapter 6 and chapter 8 if I'm not mistaken, one from but 3 exercise in total. So that one we will cover not in this lecture, because as you can see the number of pages here, 54, and we have 2 hours. This nice, we almost finished everything. Eh, I haven't written. I haven't written. I haven't written to you guys. You already have your mark. Okay, I will return to you. I haven't written. Actually, already have the mark. I will return to you. I haven't. By the way, yeah, I will return to you, but not today because I have class after this. Okay. So wait for this one. Wait for this one. I mean the exercise just now. I'm aware that we have few exercises that we haven't discussed. 3, if I'm not mistaken, from 2 chapter. So we will push them to the Wednesday, because we have class at Wednesday. So we will push them there. Okay, including this ones now. The deployment diagram, 2 deployment diagram. Okay, that one is for exercise. This one for the assignment mark, you already have your mark. I will return to you, but not today because I have class. Okay. Any more question or any more thing, issue or anything for OOAD only? Anything? If not, can we dismiss? Okay. Yes, Jonathan Ian. Okay, guys, I think bye bye. Oh, this guy. You send me the link, right? Last time I checked the link, only I think your part, but sure, can. I will check. Okay, I think we can dismiss. We can dismiss. See you guys on Wednesday. Bye bye. Thank you.